Today we're talking about quadratic equations in vertex form. So this is when they're in a form that tells us their vertex directly. Normally we're used to seeing them in standard form. So just a reminder, think about what standard form looks like. All right, so standard form looks like this. ax squared plus bx plus c equals y. Okay, or y equals that. So that's standard form. This time we're looking at vertex form. Vertex form looks a little bit different. We're still going to see our a value, but this time we've got y equals a times the quantity x minus h squared plus k. What in the world does x or h and k stand for? Well, hk is the vertex of the parabola. So for instance, if I had an equation that looked like this, y equals x minus 5 squared plus 2, my vertex would just be 5, 2, because there's my minus h and there's my k, so 5, 2 would be the vertex. A lot of times when we have it in vertex form like this, we need to convert back to standard form. So how do we do that? We're going to use our FOIL method. So our FOIL method is how we multiply these, okay? Kind of messed up my L there, but we're going to FOIL. And if you don't like using FOIL, you can always use the box method. So I'll give you an example of both of those. So let's start with number 1. Okay. So what we're going to do is we're going to take this quantity squared, x minus 2 squared, and I'm going to rewrite this. I'm going to say y equals x minus 2 times x minus 2. And then eventually we're going to have plus 3. Okay, that's just that plus 3 at the end. So foiling looks like this. We multiply the first terms, so x times x gives us x squared. Then we multiply the outer terms, so x times negative 2 gives us negative 2x. We multiply the inner terms, so negative 2 times x gives us negative 2x. And then L stands for last. We multiply the last terms. Negative 2 times negative 2 gives us positive 4. And then this plus 3 just comes on down, plus 3. So let's simplify this to give us our quadratic equation in standard form. So we have y equals x squared minus 4x plus 7. So now our equation is in standard form. If we know it's in standard form, we can find the axis of symmetry. Remember that formula is negative b over 2a. So our axis of symmetry for this one would be x equals negative b, or negative 4, negative 4, so 4 over 2 times 1. So our axis of symmetry is just 2, x equals 2. Our vertex, well, we can certainly use the same method that we've been doing and fill out this equation in our y equals and then find the table. Or since it's in vertex form, it actually tells us that our vertex, just like x minus h plus k, hk is the vertex. If it's x minus 2 plus 3, our vertex is just 2, 3. And let's go ahead and check that in our table just to make sure. So we go to y equals, clear that out, and we're going to write this equation exactly how it's written. So parentheses, x minus 2 squared plus 3. So I'm writing it exactly the way it was in vertex form. Let's look at our table. There we go, vertex is 2, 3. So let's fill in the rest of these table values. 2, 3 is going to be in the middle. Then we're going to have 3, 3 goes to 4, and 4 goes to 7. 1 goes to 4, and 0 goes to 7. This is good. We've got our symmetric table right there, right about the line of symmetry. There's our vertex. Okay. Let's go ahead and graph this. I've got 0, 7, 1, 4, then 2, 3, 3, 4, and 4, 7. So we've got a parabola opening upward with a vertex right here. There's our vertex. So what's the domain? Remember, the domain is the set of all the x and y, the x values, sorry, can't think today. It's all of the x values that this graph goes over. So the graph continues to move left and it continues to move right. If it's continuing in both left and right directions, it's going to be all real numbers. You're going to notice that all of the examples we see, the domain is always all real numbers. The range is determined by the vertex. So determined by the vertex. Okay. Determined by the vertex. So what do I mean by that? I mean that if you identify our vertex, all of the values are either going to be above the vertex or below. In this case, they're above. So y is greater than or equal to whatever the y value of the vertex is, or 3. Okay. So I told you that I would show you the FOIL method as well as the box method. So some of us like to FOIL to multiply binomials, but some of us like to use the box method. So I'm going to show you how we would have done that if we had used the box method instead. So going back to this example, we have x minus 2 squared plus 3. Okay, so we have x minus 2 squared plus 3. So we're going to remember that plus 3 because we're going to add it to our polynomial once we do the box. So we set up our box using x minus 2, x minus 2. There's 2 terms in each polynomial, so we set it up like that. And then whatever we get, we're going to add 3 to it. Okay, so let's multiply. X times x is x squared. X times negative 2 is negative 2x. X times negative 2 is another negative 2x. And then here we have negative 2 times negative 2, or positive 4. All right, we multiply like terms, or I'm sorry, add like terms. X squared minus 4x plus 4, and then don't forget plus 3, giving us what we found by foiling. Y equals x squared minus 4x plus 7. So if you prefer to use the box method instead of foiling, that's fine. Just make sure that whatever is on the outside, this plus 3 or plus or minus whatever, you continue that. You take it all the way down to the final answer. Okay, let's look at number 2. So this one has a 2 in front of it. We can actually pick out the vertex just by looking at it. Instead of it being 3, negative 1, it's going to be negative 3, negative 1. That's coming from our vertex form right up there. Okay, and we need to put this in standard form. So if we want to find our axis of symmetry. So let's go ahead and do that. So we have y equals 2 times x plus 3 times x plus 3 minus 1. I'm going to FOIL, but you can use the box method if you want. So we have here 2 times, so when we FOIL this amount, I'm going to put that entire thing in parentheses, okay? So we get x squared, and then we have 3x plus 3x plus 9. All right, so I'm going to take my work up here. I've got 2 times x squared plus 6x plus 9, all of that minus 1. We got to distribute this 2 to every single part of the polynomial. So 2 times x squared gives us 2x squared. 2 times 6x gives us 12x. 2 times 9 is 18, minus 1 gives us 17. So there is our equation in standard form. Now, you honestly don't need to put it in standard form to graph it, because we can graph this entire thing just using the original amount. And you can actually even find the axis of symmetry if you know the vertex. The vertex, or I'm sorry, the axis of symmetry is just the x value of the vertex. So in the previous example, the axis of symmetry is 2. The x value in the vertex is 2. If we know that the x value in our vertex is negative 3, that means that our axis of symmetry is x equals negative 3. It's always going to be the x value of the vertex. Okay, so we don't even need to use the axis of symmetry formula here. And we can get our points from plugging in either our original equation or the new one into y equals. I'm going to plug in the original one. So 2 parentheses x plus 3 squared minus 1. I'm going to take a look at my graph first just to get an idea of what it looks like. All right, let's check out our table. Our vertex was -3, -1. And then we'll use our calculator to give us the rest of the points. I like making my calculator do the work for me. There are our values. Vertex is here. Okay, let's plot them. Awesome, so there's our graph. Domain, it's continuing to the left forever and to the right forever, just like all the other parabolas we've had. It's going to be all real numbers. Range, look at your vertex. There's our vertex.